people on my computer. They get logged in here.
Mm-hmm.
See if I can hear you talk.
Okay. Only one person in the online. Did you join? Okay. Hello. Hello. Ye- Okay. Mhm. Mhm. Okay. So good morning, everyone. So today we are going to discuss about statistics for data science. So before doing any data science project, you require some statistics concepts just to understand the data set itself. So let's get started. So here we are at probability and statistics for data science. We will discuss about data visualization later. First, me and Professor thought to, like discuss about stats and then shift to the data visualization. So these are the concepts that today we are going to discuss. Coming to statistics, these all concepts we are going to use not only in our project. If you do any data science projects, these concepts are going to help you. So first, in this class, we mainly discuss about two concepts. One is descriptive statistics and another one is inferential statistics. And the other probability theory, multivariate statistics, statistical modeling and machine learning, time series analysis, and Bayesian statistics. This one second, we'll take care of that. Okay. Okay, yeah. Okay. So this concept, like you may not use in the projects, but it is very helpful for you to know the concepts. So in descriptive statistics, we discuss what is already in the data. Like when you got the data set, which is already there, that information can be retrieved by using descriptive statistics. So by using descriptive statistics, you are not going to predict anything. Just to understand the data sets, you need the descriptive statistics. And coming to the probability theory, probability theory will be very useful after you build the model. Because, for example, you are building a model to predict the price of the house. So then this probability theory will be very useful. And next, inferential statistics. So whatever you do under the model building, like understanding the data sets, seeing the distribution of the data sets, and building the model, like whether it is linear regression or logistic regression. So whatever the model you prefer to build, those concepts comes under inferential statistics. And regression and correlation. So anyone have any idea about regression? Like, yeah. So in regression, basically, we see the relationship between the variables. For example, when you are trying to predict the price of the house, And what are the variables you consider if you want to predict the price of the house? Do you remember like any variables that you consider? Like you need to consider the square feet of the house in order to predict the price of the house. And next, like the location of the house. And next, mm, like what and like how old the house is. So these are the variables that you consider in order to predict the price of the house. And regression is something you see the relation between your target variable, which is predicting the price of the house, and other variables like how old the house is, and in which location the house is located, and what is the square feet of the house. So finding the relationship between those variables comes under regression. And correlation we discussed in the last lecture, like finding the relationship between the variables. And multivariate statistics, basically there are like two type of statistics. Like one is univariate, like you discuss only about one variable, but in multivariate you will discuss about multiple variables at a time. And statistical modeling and machine learning, those comes under the modeling part. And time series analysis, time series analysis is basically like predicting something based on the previous values. For example, there are two values. One is at T and another at T1. So if you want to predict the price of the house at T1, you want to know the information about the at T1, like at T. So predicting the future based upon the previous comes under the time series analysis. And Bayesian statistics. Um, so Bayesian statistics is basically used to predict the probability of the output. Okay, now let's discuss about descriptive statistics. So these are all the concepts in descriptive statistics. So this, I think we already learned in our high schools, like mean, median, and mode. Those comes under measures of central tendency. And there is another concept that is measures of dispersion and range, variance, standard deviation, and interquartile range. So those concepts comes under measures of dispersion. And coming to data distribution, so there are two concepts in data distribution. One is skewness and kurtosis. And summarization tools, we have percentiles, quartiles, and box plots. So in further slides, we can discuss these concepts in depth. Coming to probability theory, these are the concepts that we discuss. Coming to basic concepts, there are probability rules, addition and multiplication, and conditional probability, Bayes theorem. This all comes under basic concepts. And coming to random variables, discrete and continuous random variables, probability distribution functions, and CDF. And coming to common distributions, there are several type of distributions. These distributions are basically the distributions of your data. Like when you got your Excel sheet, you will see how your data is distributed, and your distribution can be under these types, like any of the type. It can be a binomial distribution, it can be a normal distribution, it can be a uniform distribution, it can be an exponential distribution. So to understand how your data is distributed, you should know about all these distributions. And next, coming to inferential statistics, these are the concepts in inferential statistics. One is hypothesis testing, and there are two types in that, nulls and alternatives. And knowing about the p-values, next significance levels, and there are two type of errors, type 1 and type 2. I will explain about all these concepts in depth in further slides. And next, there are four type of tests we basically consider, like z-test, t-test, chi-square test, and ANOVA. This, see, whatever the test that we consider, explains the importance of a variable, because there are like several variables in your data set and you really don't know which variable is more important and which variable is not, right? So based upon some statistical concepts, you will decide that, okay, these variables are more important and these variables are not. So that knowledge comes under statistical test. And coming under confidence interval will describe the ranges. I will explain you in depth in further. So, and coming under regression and correlation. So these are the models that we gonna build if you have your data set. For example, simple linear regression. Simple linear regression is nothing but predicting a single variable by considering only one independent variable. So, for example, if you want to predict the price of the house based upon the age of the house, only two variables. So one is price of the house and another one is the age of the house. So age of the house comes under like independent variable and price of the house comes under the target variable. So you are predicting the price of the house based on only one variable. So it comes under simple linear regression. But when you consider like two or three variables like age of the house, location of the house, and like area of the house, like so on. So you are predicting the price of the house based upon several variables. It comes under multiple linear regression. And logistic regression, if you want to do the classification. And next, polynomial regression, ridge and lasso regression. So these are like in-depth concepts which we can discuss further. And next, coming to correlation analysis, there are three types of correlations like Pearson correlation and Spearman correlation. We know the basic concepts of correlation, right? Just understanding the relationship of a variable with respect to another variable. And in that, we have like three concepts. And next, goodness of fit measures. In simple, you build a model, but you really don't know like whether I build the correct model, like the accurate model. So based upon these values, you can decide, okay, my model is somewhat perfect and my model is really bad. I need to do some changes in order to make my model accurate. Next, in multivariate statistics, these are the concepts. Principal component analysis, PCA comes under dimensionality reduction. For example, if you are dealing with higher dimensional data and you want to reduce the dimension of the data, then you are going to use PCA. And singular value decomposition and k-means clustering and grouping. There are k-means clustering, hierarchical clustering. And in multivariate regression, multivariate linear regression, and EFA and CFA. Even though I explain these concepts in a theoretical way, you won't understand. So this slide is basically just to give an idea. Okay, these are the concepts that are, comes under multivariate statistics. Next, in statistical modeling. So what are the concepts that comes under statistical modeling? Confusion matrix, precision, recall, and F1 score, ROC and AUC, cross-validation, and bias variance trade-off. Basically, these concepts are useful in order to evaluate your model. So you build your model and you want to evaluate it, whether it is perfect or not. And you will use different kinds of measures. For example, if you are dealing with logistic regression, like if you are dealing with classification, for example, the output of your model is only like two, only one or zero. So it comes under classification. In order to do that classification model, you will use separate model evaluation metrics like precision and recall and F1 score. For example, if you are predicting something with respect to another variable, so it comes under regression. So you can't use precision, recall, and F1 score like the same measures to evaluate the model that you build. So based upon your output, you need to decide which measures I need to take to evaluate my models. So the model evaluation, the measures will be different based upon the model that you build. And next, in time series analysis, these are the key concepts and these are the techniques. These are actually the high level models like ARIMA and SARIMA models, exponential smoothing and auto regression models. So these are like, they are really like high level concepts, which we are not going to discuss in this class in depth. And so in Bayesian statistics, you will discuss the likelihood, and there are like several distributions like prior and posterior distributions. So the starting like 4 to 5 slides, I think 10 to 12. No. Like the starting 15 slides, just to give an idea, like, okay, these are the concepts, but we are not going to discuss in depth in any slide. Okay. And coming to experimental design. So A/B testing, which is an important concept, we have like a complete lecture focusing on A/B testing. So it comes under design of experiments. And in sampling methods, so these are the samplings like simple random sampling and cluster sampling. And next, okay. So those slides are just to give you an idea. And now let us discuss in depth about every statistics. Now let's start about descriptive statistics, which is the first statistics that is mentioned in the slides. So what is descriptive statistics? So descriptive statistics is nothing but you got the data set and you want to understand about the data set. So you can easily understand the data set, right? So if you got a data set which is related to prediction of the houses, like based upon different variables, you can easily understand the column name and what are the values that are present in the column. But the thing is, but you really don't know what is the mean of mean of your data set, what is the median of your data set, where are the maximum values are falling in your data set. You really don't know. You can understand the data set, but you really don't know the in-depth concepts in the data set, right? So to understand the data sets, you need descriptive statistics. So in descriptive statistics, there are like three concepts: measures of central tendency and measures of dispersion. And in measures of central tendency, there are mean, median, and mode. So in your data set, there is a column, for example, like anything, like age. If you think that in your data set, there is a column named like age, and you need to understand what is the mean value of your column, which means like what is the mean age in the entire column. For that, you need to calculate the mean. So this is a simple example. Like this, if you consider this as a data set, basically we won't deal with such kind of simple examples. But if your data set is 2, 4, 6, 8, 10, and what is the formula for the mean? Like sum of the observations by number of the observations. So 2, 4, 6, 8, 10 by total number of observations, the result is 6. So in the same way, in your column, like in your data set, you can calculate the mean value of your, like for a specific column. And okay, so for this data set, what is the mean? Simply calculating all the sum and number of observations. How many observations we have? 7. Okay. So, okay. So that is like a simple data set, like a small list I considered. But how you calculate mean for large data sets? So here, one second, I think I have a coding file. Do you have any idea like how we calculate mean for the large data sets? Which library we gonna use to calculate the mean? Just the library name is fine for me. Like which library we will use, like Seaborn or Matplotlib or Pandas or NumPy? NumPy, right? Because you are dealing with mathematical concepts, and to deal mathematical concepts, you definitely require NumPy. The mean can be calculated by using simply np.mean. So you just need to include the column name, and if you type np.mean, you will get the mean of that column. And what about median? Median is nothing but you consider a data set, for example, 2, 4, 6, 8, 10, and you will arrange the data set either in ascending order or in descending order, and you will calculate the middle. Like, for example, if it is even numbers, in my data set, like I consider 2, 4, 6, 8, 10. And what is the median for this? 6. 1, 2, 3, 4, 5. Actually, there are 5 values, right? So when the total number of observation is 5, there is a formula to calculate the mean. So that is like 4 plus 6 by 2, 5. Yeah.
So you got 4 values in a second.
Yeah, this is 6.
The average.
Yeah, average of the 2 values, and the 5 will be the median for this data set. And coming to mode is nothing but finding the most frequently occurring value in the data set. So I consider the data set 2, 4, 4, 6, 8, and 4 is the number that is frequently occurring. So the mode is 4 for the above data set, and for the below, it is 1 is occurring 2 times and 2 is occurring 2 times. So 1 and 2 will be the modes. So we covered measures of central tendency. We completed mean, median, and mode. Now we're going to discuss about measures of dispersion. In measures of dispersion, we have the range. Range is nothing but finding the differences between maximum value and minimum value. So in this data set, the maximum value is 10 and the minimum value is 2, and the 8 will be the range for this data set. And coming to variance, so here we will consider two concepts. One is population and another one is sample. Basically, in statistics, whatever the observations that we do for the population are based upon the sample. Because like if you want to calculate for the entire population, you can't calculate it, right? Like you can't do that because you can't bring them all and you can't do the like calculations. So whatever we will do, so we will consider the sample first, and whatever the results that we get for the sample, we will finalize for the population. And these are the formulas to calculate the variance for the population and the samples. So here, if you consider in sigma squared, which is for the population variance, we have population variance and individual population value, and n will be the total number of population, and sigma square will be the variance of population. So in your homeworks or in your midterm, like you will get like simple questions like find the variance for the population or find the variance for the sample. And you need to decide whether we are dealing with the population or sample based upon the question. And here, this is the sample, and this is the formula for the sample variance. And next. So here I consider the data set 2468. The mean will be the 5, like 2468 by 4. And what is the variance? So here we will consider a single value from the data set, that is 2, and we will minus the mean, and we will do the square. And like that, we will continue for the entire data set, and the variance will be the 5. So this is how you calculate the variance. And coming to standard deviation. Standard deviation is nothing but the square root of the variance. Like in previous class, I brought a distribution, right? Like normal distribution. So variance basically, like standard deviation basically explains the variance of your data, like how well your data spreaded from the mean. And that will be provided by the standard deviation. So if you calculate the variance by doing the square root of the variance, you will get the standard deviation. And interquartile range. So this is the formula for the interquartile range. It is the range between 25th percentile and 75th percentile. So anyone have any idea what is 25th percentile? Like what does it mean?
First one, part 2,
Yeah, like if you calculate the 25th percentile, for example, here Q1, for me, the Q1 is 4, right? So the thing is 25% of your data falls below that value. That is the concept behind the 25th percentile. And what is 75th percentile? So whatever the value you find for the 75th percentile, like 75% of your data falls in that range. And what is IQR? So IQR is nothing but the like 50% of your data. It means, so whatever the range that 50% of your data lies, that range will be interquartile range. And it's important to remember 25th percentile, 50th percentile, and 75th percentile. 50th percentile, we call it as median because we are concentrating on these like center values. And here is the formula to calculate for a simple IQR. I consider the data set 2, 4, 6, 8, 10. And Q1 is the 4 and Q3 is the 8. And these are the values for the IQR. So Q1. So these are the steps to calculate for the 25th percentile. Like in your midterm, you can simply see like any question like calculate the 25th percentile for this data, calculate the 75th percentile for this data. So most of the students, they used to write the formulas like very wrong. They will keep like Q3 plus Q1. Some people, they used to calculate Q4, but I really don't know where they got Q4. So please make sure you remember these formulas. So here, how to calculate the percentiles? First, you need to arrange the data in ascending order. So whatever the data that you get, you need to arrange it. And next, sort the data set from small to largest and find the rank of the percentile. The rank for a given percentile is calculated using, this is the formula. So this is the formula to calculate the rank. And in that, P will be the percentile. For example, 25 for Q1 and 75 for Q3. For example, you want to calculate the 25th percentile. The P will be the 25 by 100 into N, like total number of observations. For example, in previous, we consider.
I use the median for an example too, because
Okay.
in this place you take the median is 50 is, you know, 50, 1/2, and you want to take the number of observations plus 1. So 5 plus 1, 6, take half of that. You get 3. That's just 6 in the middle, right?
Mm-hmm.
So
you are taking N.
For the median. N is 5 in that case.
You're talking about Q1 or median?
Q2.
Q2. Yeah, I'm talking about Q1.
Yeah. So Q1 and Q3 are the same thing.
Yeah.
Take it to the different percentile. So
yeah. I'm just telling them like how to calculate the Q1.
Example.
Okay. So
you got example on next slide.
Yeah. Okay, so if you want to calculate any percentile, you need to consider this formula, like P by 100 into N plus 1, and will be the total number of data points, and P is the percentile that you are calculating, whether it is 25 or 75 or 50, whatever the percentile. And so this is a simple example explaining how we calculate Q1 and Q3. So first, this is the data set, like 2, 4, 6, 8, 10, 12, 14. And if you observe, it is already sorted. So first you need to sort the data set. Don't forget. So when you got the data set, don't jump directly calculating Q1 and Q3. You first need to sort the data set. And what is the total number of observations? It is 7. And for Q1, which comes under 25th percentile, so 25 divided by 100 into the total number of observations, 7 plus 1, so which is the 2. And this is the formula to calculate 75. The result is 6. So Q1 is 4 and Q3 is 12. So the second value is 4. The second value in your data set is 4 and the sixth value is 12. So as we consider a simple example, we can easily see the data set and we can know what is the second value and what is the sixth value. But for large data sets, we can't do these calculations, right? So yeah, we use NumPy. But this is the math behind those calculations. Data distribution. So data distribution is nothing but how your data points are spread across the data set. You need to understand how your data is distributed. And Because you need to understand like what is the shape for that, what is the mean for that, what is the median, so that you will understand, okay, most of my data is falling on the left side or most of my data is falling on the right side. So this is the mean of my data. So in order to explain your data, you should know this distribution. And coming to the shape of the distribution, there are two types. One is skewness and one is kurtosis. And okay, so what is skewness? It is the asymmetry of the data set around its mean. So it tells us if your data is symmetric or not. Like for example,
We want to see. But it starts, I'm gonna try to get.
for example, if there are two type of distribution, something like this, and so, like something like this. So here, so the thing is, so see, I don't know whether everyone can see that. Okay, done. So this is one type of distribution, and this is one type of distribution. Here, if you observe, most of your data is on the left side, right? So here, the tail, this will be the like tail. So this shows that most of your data is on the left side. But if you observe that here, the most of your data is on the right side. So skewness basically explains this concept. Positive skew, the tail is longer on the right side. So this one towards the larger values, because if you observe the real numbers, the left, like right side will be the larger values and the like left side will be the negative values. The mean is greater than the median. So here, if you observe the mean of this distribution, which will be always greater than the median. So it indicates that most data points are clustered on the lower end of the scales. So yes, like clustering is nothing like grouping. In simple, cluster means group. So if you observe here, most of your data is on the left side, which means that most of your data points are clustered on the left side. And if you observe that graph, it comes under negative skewness. One second. See, negative skewed, which means the left part is skewed. The tail is longer on the left side. So if you observe this graph, the tail is longer on the left side. The mean is less than the median, and it indicates most data points are clustered on the higher end of the site. So this is how your distributions will be. Like if you get the data set and if you saw the distributions, you will get this kind of graph. Actually, you will get different kinds of graphs, but it's important to understand this kind of distributions so that you can understand like where the most of your data is falling, whether it is falling on the right side or whether it is falling on the left side. And next, zero skew. Zero skew is nothing but like normal distribution, simply the bell-shaped curve. Okay, here if you consider this is the mean. So this is
Make sure.
okay.
Back and forth. Sorry.
Okay. Okay. So zero skewness. So it means that your data is like equally distributed on both the sides. If you observe, like I don't know whether anyone knows the data processing. So whatever the data processing steps that we do in our data sets, basically to make our data like more symmetric and like making our data such that it will be on normal distribution compared to skewness, like positive skewness or negative skewness. And
term sharing. I'm sorry. Sorry, just technical difficulties due to the
yeah, the podium
feeder being down. Yeah, so But what I did was I shared on my phone long enough to show the video. And so that shut off the
Okay.
sharing on here. So, and I don't know when I turned off the sharing. A lot of ways. Okay. Sorry.
So this is basically the concept of skewness. And if you observe the data sets, so we are calculating the mean and median. If you observe data 1, the mean is 10.62 and the median is 5.5. So positive, it's a right skewed because of the outlier 50. So what do you mean by outlier? What is the meaning of outlier? Any idea? Okay, if you observe that data 1, we have like several values, right? 2, 3, 4, 5, 6, 7, 8, and 10. So which value is not like normally not considered in the data 1? That is 50, because it is like way higher than the normal values that we consider. In real life, we discussed in first lecture, like the salary of the board members will be very higher than the salary of the employees. Then the salary of the board members will be the outlier if you compare the salary of the employees and the salary of the board members. That is the reason we use standardization, so that like whatever data you consider, it will be on a single scale. And if you observe data 2, I calculated the mean for the data and median for the data. And if I observe the skewness, it is negative, like the left part is skewed. So this graph I will get for the second data set, and this kind of graph I will get for the first data set. So this is a simple example explaining the concept of skewness. Okay. Only one person in the online. Okay, 1 second. Where is the PPTs? The PPTs. I don't know where it is. I'll tell you.
Yeah, okay.
Okay, done. So that is the concept of skewness. And coming to kurtosis, so what is the meaning of that? So it measures the tailness of your data set, or how heavily the data deviates from the normal distribution. So you got this kind of distributions, but you need to know how well your data set is left skewed, or how well your data set is right skewed. And that can be measured by using the formulas. 1 second, let me go to next slide. Yeah, so this is the formula to calculate how well your data, whether it is like left or right. These are the formulas. You can simply consider some data points and you can calculate this kurtosis. And here, if you observe, you will be the mean and will be the total number of data points. This you can calculate in your free time if you need. So this is one of the example showing like how much your tail data set is on the left side or on the right side. And 1 second. So coming to summarization tools, in descriptive statistics, there is one more concept. Actually, there are 3 concepts. One is percentile. We already calculated 25, 50, and 75. Coming to quartiles and box plots. So this all 3 concepts is basically used to divide your data sets. So if you want to divide your data sets into different parts, by using this concept, you can divide your data sets. And if you observe like box plots, anyone have any idea about box plots? So, okay. So box plot will be in this shape. A simple box plot will be in this shape, and it is basically used to find the outliers. So when you when you see the distribution of your data set, like whether it is a single column, so whatever the values that falls in the range, For example, here, so it's Q2, Q1, and Q3. Q1 minus Q2, we will get IQR, and Q2 will be the median. So based upon this range, so whatever the values that fall, like here and here, will be the outliers. Because you really don't know, by seeing the data set, you can't say, okay, these are the outliers, right? So by using some like graphical representations, you can observe, okay, these are the outliers, I need to remove them or I need to handle them. And next, this we already discussed, right? So percentiles 20, 50, and 75. And this is the data set. And we calculated Q1, Q2, and Q3. Definitely, there will be one problem related to box plot or related to IQR in the midterm. So make sure you remember these slides, or just the formulas are fine. Next. Okay, this we already discussed. What else? I don't know. 1 second. Okay. Done. Box plots. Okay. So coming to median, this is already done. Okay. So now now you need to find the lower bound and upper bound for your data sets. You calculated the Q1, which is 25th percentile, and that is the formula to calculate the lower bound, like Q1 minus 1.5 into IQR. In IQR, you will substitute Q3 minus Q1, and that is the value you will get, like minus 6.375. So adjusted to minimum data value 5. So if you get that negative points, and it is adjusted to the 5. And upper bound, this is the formula that you got for the upper bound. Yes. So Q3 plus 1.5 into IQR, and that is the formula to calculate the upper bound. And any outlier greater than 32.625. Here, if you observe the upper bound, we get 32.625. So any value that is greater than 32.625, we will get it as an outlier. So I already said that this range will be the outliers, right? So if you observe that if 32, if this is the value of 32.625, so whatever the value is greater than 32.625 will be the outliers. And whatever the values less than this 6.375 on the negative side will be the outliers. So whisker limits are basically used to calculate the outliers. In your free time, just go through these formulas. Coming to probability. So we discussed about the outliers and the whisker limits and interquartile range. Coming to the probability rules. First one is the addition. It is simply nothing but probability of A union B equal to probability of A, B, and probability of A and B. For example, like negative, okay. Like probability of A equal to 1 by 4 or probability of B equal to 1 by 3. So these are the individual probabilities for A and B from a deck of cards. And I calculated P of A and B, which is 1 by 52, as we consider the cards here. Then that is a formula to calculate P of A union B. And multiplication. So these things you can simply observe the slides and you can understand. For example, if I consider the probability of rolling a 4 on a dice. So for example, if you roll a die, what is the chance of getting 1? Like what is the probability of getting 1 or 2 or 3 or 4? Yeah, 1 by 6. And if you consider flipping a head on a coin, 1 by 2, because there are only two events in the sample space, that is head and tail. And that is a formula to calculate the probabilities. And this is related to conditional probability. So conditional probability is nothing but the probability of A given B. So what is the probability of A with respect to B? So in conditional probability, if you want to know about A, like we need the requirement of B. And that is the formula to calculate conditional probability. And this is the example. Like if 30% of students are good at maths, so which is probability of M, and 20% of students are good at both maths and programming, then the probability of being good at programming, given that the student is good at maths. So this comes under the conditional probability, and that is a formula to calculate it. Okay, so there are some problems in the probability slides. So just go through those slides in your free time. And if you have any doubts, you can just text me in the Blackboard. And this is the Bayes theorem. So this is the formula for the Bayes theorem. Bayes theorem is basically used to calculate the probability of an event with respect to other. And that is the formula for the Bayes theorem. And this is the example. So even if I explain, it will be like a very long explanation. So just go through the slides. And random variables. There are two types of random variables, discrete and continuous. The discrete random variables, it basically counts the number of values. For example, if you observe, like if you toss a coin, so you will get either head or tail, so which comes under the discrete random variables. But if you consider the height or a weight, so which is always a continuous, so it comes under the continuous random variable. So those are the simple examples. For example, if you consider the height of your students in a class, it will follow a continuous distribution. For example, in our class, if we see the distribution of the height, so it will be a continuous distribution. And next, this is the formula for cumulative distribution function. So the thing in simple, like what is cumulative distribution function? Which means, for example, if you roll a dice, and we will calculate, like for example, if you consider x equal to 3, so what are the probabilities like which are less than 3? For example, if I consider here x equal to 3, and by using cumulative distribution function, I will calculate the probabilities for 1, 2, 3. So what are the values that can fall below the 3? Those can be calculated by using CDF. And if I consider x equal to 4, so I will calculate the probabilities of the values that are less than 4. So 1, 2, 3, and 4. And so this is the binomial distribution. So if you observe this curve, which is related to that, it comes under the normal distribution. It is used for discrete variables with a fixed number of trails and the probability of success P. So binomial distribution is basically used for discrete variables. For example, if you roll a dice, you will get 1. And if you roll second time, you will get maybe 2, 3, 4. We really don't know. So that kind of distributions comes under binomial distribution. And this is the example, like if we consider flipping a coin 10 times, and we know that the probability of getting like head or tail, which is 0.5, and this is the probability that we calculate for x equal to 5. So I toss the coin 10 times, so 10 into, and the probability of getting either head or tail, which is 0.5. And as I consider x equal to 5, so that is the like value that I will get. So these things, basically, when you do yourself, they will be understand more compared to the, compared to the explanation. And next, coming to Poisson distribution, it basically explains the number of occurrences of an event in a fixed interval. For example, if you consider a fixed interval, like in the range like 1 to 5 or 5 to 10, and if you want to know the distributions between in that range, so it will be explained by this distribution. And next, Coming to normal distribution is the one which seems like a bell-shaped curve. For example, if you observe the height of people, so it will follow a normal distribution. So this is the example for the normal distribution. And if you want to calculate like all the distributions before a certain value, you can use the CDF. So here I considered x less than or equal to 180. Like I consider the probabilities of all the people like whose like height or weight. Yeah, height. So height is less than 180 centimeters. And so this is uniform distribution. And it will explain the equal probabilities over a range. For example, if you consider that image, we calculated the uniform probability distribution over the range 2 to 6. So if you observe like 2 to 6, we have the values. So uniform distribution is nothing but for a certain range, all the values will be the same. And if you observe the left part or the right part of that distribution, it may differ, but for a fixed range, you will get all values as same. And probability theory, this is simply the exponential distribution. And this is the formula to calculate the exponential distribution. So if you observe that graph, so if you observe that graph, like three, like blue, orange, and green. So they started at a single point at the beginning and they started to increase. And this kind of graphs we basically consider as exponential. So if when your data have this kind of distributions, it comes under exponential distribution. And coming to inferential statistics, there are basically two type of hypotheses. One is null and alternate. The thing is here. So what do you mean by null and alternate hypothesis? So anyone have any idea? Yeah.
The null hypothesis is pretty much what you're assuming to be true, and
Yes.
the alternative hypothesis is what you're testing. You're trying to disprove the null hypothesis.
Yes. Yes. So here there is a example. So the factory claims that average weight of its product is 500 grams. So this is like, you can consider it as a statement. So what is the null hypothesis? The average weight equal to 500 grams. So what is the given thing? So we will consider it as a null. And what is alternative hypothesis? So there are two cases. The average weight is not equal to 50. Either it is greater than, not equal to 500. Either it is greater than 500 or equal to less than 500. So it comes under the alternate hypothesis. And coming to the p-values. So p-values basically explains the significance of the variables. Like we discussed before, if you have several variables and you really don't know which variable is more important to consider in your model. So based upon the p-values, we can check the significance of the variables. For example, if you observe, if p-value is 0.03 and the significance level is 0.05, we reject H0 because there is only 3% probability that observed difference occurred by chance. So here we consider the significance level is 0.05. The thing is, what is meant by significance level? Anyone have any idea what is the meaning of significance level?
If the probability of the test statistic is at or below that level,
Yeah.
we reject H0.
Yes.
Yes.
So
The value is significant.
yes. So here the significance level is 0.05 and the p-value is 0.03. So the p-value is less than the significance level. So as the p-value of a particular variable, let us consider it is the p-value of a certain variable. As the p-value is less than the significance level, we will reject it. We will reject that variable. So in that way, we can decide that, okay, this variable is more important and these variables are not. And we can change the significance level. It can be anything like the basic consideration is like 0.9, like 0.05, but you can consider 0.08 if you want like 98% of confidence interval. And yeah, so the significance level, this is the definition for that. And this is simply the example. And here, okay. So this graph is really important. So what is the shape of this graph? Normal distribution. And if you observe that the green one, so that is where the p-value lies. And whatever the values that fall after that p-value, so they are like unlikely observations. So the both sides of that range, and we will reject those variables. And here, whatever the values that fall in the middle, we will consider those variables are like highly significant, and we will consider those variables. So a p-value is the probability of an observed result, assuming that the null hypothesis is true. So the shaded region is called the p-value. And based upon that p-value, we will consider the significance of the variables, whether they fall below the p-values or they fall above that. And so we already discussed about null and alternate. This is another example. For example, if you read this, it's just the company developing a new drug to the lower blood pressure and wants to test its effectiveness. And here they considered like two. One is null and alternate. So what is the null hypothesis? The drug has no effect on the blood pressure. And what will be the alternative? So it has some effect on the blood pressure. So either it can be a negative or it can be a positive, but it has some effect on the blood pressure. And there is one more, like, so here comes under that t-test and also that z-test. When your sample size is less than 30, we basically consider the t-test. So based upon the sample size, you need to decide which test you need to perform to identify the significance of the variables. So here, like one sample t-test comparing the mean blood pressure reduction of the patients taking the drug to 0. So there is a scenario like after testing 30 patients, the average blood pressure reduction is 5 mm with a p-value of 0.02. So what is the conclusion? If the significance level is 0.05, we reject H0 as p is less than 0.05, because if you observe the p-value, it is 0.02 and it is less than the significance value, which is 0.05. And as we reject the null, we accept the alternate. So saying that the drug is effective, like the drug is affecting on the blood pressure. So when you reject the null hypothesis, you will accept the alternative. What is the alternative here? We consider the new drug is having some effect on the blood pressure. And
10:30, we should probably skip to that.
oh my God.
You just go on your own. Like one, like
That is
two.
the reason. Yeah, okay, okay. So this, in your free time, you just go through the slides and let me know if you have any doubt, because we don't have the time. And I need to explain the project too. So this is the confidence interval.
Yeah, you might mention the type 1, type 2
Yeah.
errors.
Oh, okay.
That was back on slide
So 1 second.
57.
1 second. Yeah.
Yeah.
Type 1 and type 2 error. Actually, I missed keeping a small image in this type 1 and type 2. Like saying that the man is pregnant and the woman
We'll
is
do
not.
that in the next lecture.
Oh, okay.
Yeah, but that's a good thing.
So there are two type of errors. One is type 1 error and type 2 error. So what is type 1 error? Like false positive. Like in simple, false positive is nothing but like, yeah, for example, like it occurs where the test wrongly concludes that the person has the disease. Okay. So for example, you don't have the disease, but in the test, like you got that you have the disease. So it comes under like type 2 error. 1 second. Oh, okay. If in simple, nothing but if a person has the disease, but the actual thing is he don't have the disease. So it comes under type 1 error. And the opposite will be the type 2 error. So the person does not have when they actually do. So the person have a disease, but the thing is we in the test we got that they don't have the disease. So it comes under the type 2. And there are other names for the type 1 and type 2, which is false positive for the type 1 error and false negative for the type 2 error. There is a lot of slides, but the information will basically the same that we discussed before. I covered all the concepts. In your free time, just go through the slides. It will be mostly the same. Just explaining one concept in 4 to 5 slides. So this one.
Confidence interval. Go back to the picture.
Okay.
So the confidence interval is the opposite of the significance interval,
Yes.
right? So
if you observe the graph, like confidence interval estimate the range in which a population parameter lies within a confidence level. For example, if you see the graph, and here we consider 95% confidence interval, and that 95% will falls in the middle. If you see that arrow, it represents the 95% of the values. So the confidence interval will explain like where your most of the variables will fall, like most of the data will fall. And after that, like whatever the values that are in above or below, we can reject that. Okay. So this is the formula to calculate the confidence interval. And this is a simple example to calculate the confidence interval. So you just need to substitute these values in this formula and you can calculate it. So can I jump the project?
yeah,
Okay.
the alt tab.
Okay, once again.
Alt tab will get you to the next one. You just keep hitting tab over and over until you get to the right.
Oh my God.
Now you don't move the mouse. Just
Okay. So this is related to the project. I have some upcoming tasks. So in this stage, so what is the task that you need to do? We will give some like, what is that? Some data sets, like data sets topics, and you need to decide the topics. So 1 second. Yeah. Yeah, that what I'm planning. So these are the topics. So you need to select one topic, the team member or with your teammates, you need to select one topic and you need to submit a document. So after selecting the topic, you need to submit a document, including like your team name and why you choose those topic. And yeah, so once you select the topic, that topic will be finalized and we will provide the data sets. So once the topic is finalized, you can't change the topic. So please go through these 2 slides. Parkinson disease. So here the topics like human activity, bank, automobile data sets, mushroom. So discuss with your teammates and decide one topic and submit a document. And the due date, Friday.
yeah. We got what's on to keep going. Just keep slide. There you go, document.
Okay. Yeah. So this is what you need to do. You need to upload a document. And these are the things that you need to include in the document: the team name, logo, your project name, and the student names with their IDs. And in the document, you will explain why you choose those topics.
Data sets in our projects.
Okay.
So
We'll take that.
yeah. So what we'll do in the project, we'll give data sets, and you are going to work with the data sets in your project. Okay. So we don't give the data sets now. First, we'll choose the topics. So you will be sticking with your topics. We won't show you the data sets, but you select the topic, and then we will give the data sets for your topic, for the chosen topic. So this Friday, we'll give you an Excel sheet or a spreadsheet. We'll share you the spreadsheet link this Friday, and we'll have the topic names on one column, and you can enter your team name on the second column. Okay, so one data set for one team. So we have enough data sets, so we'll keep the data set list, and you just enter the project, I mean team name on the second column. Okay, so you won't be seeing the data, but you will see the data, I mean the data set's name topic. So selecting topic, how do we select topic without looking at data set? So when you work, if for your employer, so do we have a choice to choose our project at work? No, no, right? So we should work what they give, right? So at least we have an option to choose the topic. So just choose the topic, but you won't have an option to look at what the data is inside your topic. Okay. So data sets, we have human activity recognition from sensor data. So we have different sensors like accelerometer, gyroscope, and magnetometer, different sensors. So we'll extract the data from the human activity. So if I'm doing this activity, like lifting the hand up and down, so we have the sensors right here. And these sensors, we collect data for every second, or we'll collect like 50 data points for every second, or whatever the hertz, I mean the 50 hertz or 60 hertz of data. So that's what this hair data set is all about. So it collects the data from the sensors. So that's human activity recognition. So from the data, we'll recognize what's the activity of the is performed by the human. Bank marketing, it's again a churn data set. Most of you may know that the bank marketing, so whether the person will take an insurance from the bank or not. So something like that. Automobile data set, so that's the information related to cars, car sales, or car models, and everything. Mushroom data set, so it's something like iris data set. So we have like different types of mushrooms. So many types of mushrooms. So we have the data set related to mushrooms. And spam base, so that's the email data set. And breast cancer data set. Forest fires, so about the forest fires in United States, we have the data. And it's like doing some kind of regression or predicting like how many fires gonna happen the next year, something like that. You're going to figure out the question from your data set. Optical recognition of handwritten digits. So it's again, it's not the image data set, it's the text data set again. So the data set has the curves on the number and everything like that. So if we have a number like this, again, yeah. So again, it's not the image, because we are not discussing neural networks in this class. Yeah, that's okay. We'll finish. So we're not discussing about the images or anything. So we'll just give the numbers, and you will recognize the number. Yeah. Parkinson's disease dataset. So that's again something related to HAR dataset, because it's a neurological disorder. So the people having Parkinson disease may not, work like what we do. Like I'm moving the hand like this, but a Parkinson disease patient may not move the hand like that, because he has a lot of tremor. I mean, a lot of movement in his hand. So when he moves, he will like move it with, the tremor. So again, the data collected by the sensors, so that has a lot of ups and downs in the data set. So that's how you recognize the difference between a Parkinson disease and a normal person. So that's what Parkinson's disease data set is all about. And apartments for rent, in the name you can say that. And this is National Poll on Health Aging. Unhealthy aging. So that's about the people and the health in the United States again. Water quality prediction, arrhythmia dataset, that's another disease. Travel reviews, and room occupancy education. Polish companies bankruptcy, that's again for the United States dataset. Facebook metrics on cosmetics brands, image segmentation dataset. Parkinson's disease classification datasets, it's again, that's the detection dataset last we discussed, and this is the classification, like whether the Parkinson disease patient has, mild Parkinson disease or severe Parkinson disease, and something like that again. And the pedestrians in traffic dataset. So these are all the datasets we have. So we will keep these topics in the spreadsheet, and you are going to fill your team name beside the topic you want to perform your semester project. And again, one team for one project. So we'll just see the the number of groups we have, and we'll give the number of topics, so that each group can select one topic. Okay. And be extra careful in choosing your data sets, because data sets won't be changed later in course. You will be working with the topics you choose. So after you choose the topic and after you look at the data, and if you feel like this data, I can't work this data, so that's not gonna work, you will be sticking with your data. Okay. So we won't be changing our data sets later on. The topics will be shared in an announcement on this Tuesday. This Thursday. So by tonight, I'll just share the topics in the announcement for tonight. And tomorrow we're going to give a spreadsheet to choose the topic. Yeah. So you can just look at the topics and have an idea. Submissions. So submissions is this Friday night. So just the first, it's a simple submission. Prepare a document. So for the first page, just give the team name and logo you have prepared. Just insert the logo in the first page, project name, the name of the topic, and the student names. That's the first page. And in the document, explain why you choose the topic. For example, if you choose the Parkinson's disease, just say why you have chosen the Parkinson's disease dataset, because it's a neurological disorder. Most of the people are suffering from the neurological disorders, mostly the elderly people. So we are trying to save the lives of elderly people by detecting them in early stages, something like that. Just write some story about the topic why you have chosen and submit it. That's it. So I will create a submission tonight. So you can write your document starting tonight. Yeah, that's the submission on Friday night. So take your time, choose your time. No page limit. Not expecting large documents. Even it's like 2 pages, that's fine, because one page is full of your names and everything, and one page have some 1 or 2 paragraphs. That should be fine. Not expecting large documents, because there's no time to prepare large documents. So if you have any questions related to project, so we will upload this slide. You can mail it to the professor and CC both me and Harika, who is teaching this course. So just CC us, and should be mailed by team leads. Not everyone in the group can mail, just the team leads. That's the job of team leads. Just mail your questions from team lead, not everyone. So add CS 746 project at the start of your subject line, so that we will have like, okay, this is the mail related to project, and we can respond quickly. If that's the subject you haven't included at the start, then we may miss and or we may reply you late. Okay. So example, you can see the example of how. So last day to submit your documents this Friday. Okay. One submission per team. So we will create a submission in your project groups. I guess you know how to look at your project groups in the Blackboard. So you have the submission over there, and you can just submit your document, one submission per document. So if one of your team members submits, then all of you will get the mail as submitted. Okay. And good luck with your first project document. That's it. And let's go for attendance. Time. Stop sharing. You can just. Okay. Oh my God. Black. Just have to give me credit. Apologies for keeping you here late. Come on.
It's fine.
Yes, you can do better. Yes, 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 we can do better. There you go. Again, this is an attendance quiz. If you need to go someplace, just go out there, pick the first number, right, that question, answer it randomly, click submit, you're done. We can go over the actual questions later, but so you don't actually have to finish this if you're in a hurry, because we're keeping you late. Because why? Because
Of WSU.
we blame the WSU camp computer here. Yes. Yes, I do. I have had iCloud installed before. I'm not seeing. Oh, I can use Type C. Yes, I can use Type C. Yes.
So Harika can use her own laptop.
Yes, and she tried plugging it in and it wasn't working right away. And we're like, she was like, I was like, mine is all set up. You want
Oh,
to try it? So we did mine. So, because I didn't show up until like 9:27.
Okay.
Yeah, because I sauntered in late,
Uh,
or even later. Don't try to sound so much.
there's a large truck in the middle of the road before I park. It's like, we need to give the space
Yeah,
to
okay, yeah.
oncoming traffic and
Yeah, okay. So, question for the students that showed up late today. Was it A, riding the bus and the bus was delayed? Was it B, you were just driving late? Was there C, something else?
Parking issue.
Parking issues, okay. About other people? Parking? Because we were like guessing that some of the people are coming in because the bus was arriving late, because
Parking.
but it's the parking, yeah, okay. So I'm gonna throw an idea out there for you that need to park. Up north of campus here at 21st and Yale, there's a church and there's a parking lot next door to the church that actually is parking for Wichita State. It's a deal the church and the university made together. So you can actually park up there, walk down through Devlin Hall and Hubbard Hall and get here.
and it's free. You don't need to
It's free. You don't
pay
even have to have parking.
$70.
Yeah, you don't have to pay for parking to park there. So you don't have to pay for the student parking. So I'm going to throw that out there for everybody. And if I do this wrong, it'll get filled up and I won't be able to park there anymore. That thing is so empty. There's so much room. Okay. It's at 21st at Yale, just right down the street up here, just north of Devlin, on the other side of 21st Street. And there's a church there, University United Methodist Church. And there's a parking lot just on the west side of Yale across from the church. It's actually a church parking lot, but
He says
they
10
share with
pages.
Wichita State.
Actually, it was
And
less than
I
10.
believe there's cameras up there.
No.
So you're secure just like the on
We have
that works.
I believe
I tried my best to make it longer, but cannot make, including the reference, it was totally 10 pages. And my final page, it was just half. Before the reference, It doesn't matter. I try my best.
Yeah. Let's see what happens.
10 pages.
But his queue says if someone wants extension, can just
Yeah,
email.
he can, if we can just mail, but I guess we will be too much picky.
I try my best. Do I make it?
Is it for your PA?
Yeah.
Yeah.
Yes,
Whoever you want, whoever.
we were classmates.
Yeah, he's a very cute guy.
Alright, so I need to go.
Yeah.
He has grades for the piece.
Uh-huh.
He shows the answer. No, he didn't show the answer, but he showed the grades
Okay.
percentage.
Okay.
It's okay.
Yeah.
Okay.
See you on Monday. Yeah. Yes, PTS.
Sure. I don't think I have SharePoint. It's just like a new team. It's Melissa Hawkins. Sure.
Let's see. If it works. Just
First of all,
And-
go ahead and log out here. Take my shit and go. That's it. I'm stomping out of here in disgust.
So we can't use mic, right?
No, yeah, you're gonna use the microphone on your your laptop.
I can do one thing, like I can use my AirPods.
What,
I can use my AirPods. It will be more clear.
for you?
Yeah, for me.
Yeah. Want to just hear yourself? Although you don't need to hear yourself, you just use the microphone, you're just using the microphone, right?
I mean, I use this one so that if I hear
Yeah.
handwriting, so
Oh.
the microphone.
So you've got this one's here. Oh, yeah, you put those in there now. But also, you know, the old modular pods. Don't ask me. Like you do all day.
Okay, but waiting for your call. It's calling.
Oh. So, one for a bit bigger.
I suppose we have. We have time. We have.
Yeah, so for the project, you need to discuss that. Dan. So you start putting up your, you're coming up here. On here, we're gonna use, look at this. If you wanna find what the name of the computer is, you log in as dot backslash.
I have been at Email, I think you should.
Just. Where's the send shop?
What? What, you want to go download or what? What do you?
Yeah, downloads, in downloads, I believe. Downloads.
There you go. Grade 4, grade DP, the grade 4 first course.
Yeah.
I tried like 10, 20.
And so I sent on.
I don't know if I can name the good thing.
If you want me to take over at any point
Okay.
and assist, I'll be ready. I can do it. If you want me to do the whole lecture. I'll be the chief, this going to not what I'm concerned with. I guess, because I know I'm gonna stick you with one. In the near future.
Let's see how.
Yeah, yeah, issues. So what do you do?
Yeah.
See, why can it work? Might need to jump on.
That's not there, can
That's okay. You can see the quality right there.
Yeah.
Yes. No, just switch on the light.
But,
Switch on the light.
yeah.
Yeah, that is.
Yeah, okay.
I want to build this side policy. So I mean, to.
How do we go to the screen? We can go there and plug it into.
I will.
That's okay. But what is the amount?
Sorry, good question.
That's not, is it? No?
Just close the articles.
I'll do that. A new one.
You speak now.
That's okay. Maybe she had a call. I think. Yeah. Let's see if she's out in the hallway. Hello, Harika. Saturday, isn't it? Yeah.
That be the queen only. Yeah. Using of it. This of course, really electronic. Not gonna ask any question, this introduction. You have any forward, we'll have to. Nothing. It's something like, if you want to take a risk, but I just took a risk, but called it very hard. You just still is happening. I just took a risk, but I just called it. And then, later, after you feel like that. So you can have a double start, just start doing it. After that, you call it. That's
Interview on what we get.
interview maybe as.
What exactly?
Things to work out. I think what you say. That's. Do we have any work experience? We just. That's.
Then somebody has 2 years.
I see interview around and people.
I think I just started with them. It's very consistent.
Because it can't be related. You know, before that, before applying on the. You got to know that about applying. And you got that, you know about fees. That's common, what do you do and like management? It's a bit of a sum. We'll have to you.
Big crowd today.
Ooh.
And there's this one.
Do you just plug it in and that will work?
Just plug in, you have to.
But then maybe
You should go to your desktop. Oh, shoot. So in order to display this, we need to make sure we do another one. If we see over here, oh, yeah. I can see. Okay, we see my hand. Oh. And now you stretch your 3 meters. So you can set.
Yeah,
So, yeah. I don't know why people have their screens up here.
it's really powerful. It's a default one.
Yeah, but we have those. Leave it. I'm gonna turn this off for the presentation part. That's Mars.
Gesundheit. What are we doing and why is it backwards? It's current. That's okay because we can see the screen in the room and it will be reversed on, so it's reversed for you, but people that are dialing in should see it forward. I'll verify that. Yeah, I'll verify that. They're trying to make it more convenient for everybody, but